What Energy Does is a physical science unit incorporating ideas about the relationship between speed and energy transfer, and simple machines. Let's look into the unit at a glance. This unit covers several fourth grade physical science standards about energy and speed, energy transfer, collisions, work, and simple machines. Each of the next generation science standards correspond to a Missouri Learning Standard listed in parentheses on this chart. Take a moment to pause the video and review them. In this unit, students try to engineer their own machine that will solve a problem. The anchoring phenomenon used to connect students to the science content is a video of a girl who creates a machine to help her take out the trash. So what does she need to know to create a machine that solves a problem? After each lesson, students will reflect to consider what they have learned that will help them figure out the answers to the questions they have about creating machines to solve problems. The design challenge for this unit is a culminating activity in Lesson 9. Closely connected to the anchoring phenomenon of a girl creating a machine to take out the trash, students are tasked with designing a machine that solves a problem of their choice. They research how simple machines make work easier and observe how energy transfer helps a machine operate to solve a problem. Now that we have an idea about what students will study in this unit, take a look at the unit flowchart. This unit is divided into 4 sections and there are 9 lessons total. In Section 1, students observe that evidence of energy can take different forms. This section will take about 5 instructional days. Here are some of the content-level big ideas for Section 1 and how students will figure them out. Students identify evidence of energy in their daily life and make the connection that energy makes things happen. They will continue to apply this knowledge to the other sections of this unit. Students then narrow their discussion on energy, focusing on how motion is evidence of energy and how the amount of energy put into a system affects the energy output of the same system. Section 2 asks students to dive deeper into energy transferring during a collision. This section will take about 10 days. Students collect data from a series of collisions and collect evidence of transfer of energy to conclude that when objects collide, energy transfer can be observed through change in motion, sound, and heat. Students then analyze data from a series of investigations to determine that the more speed an object has, the more energy that object has. The more energy an object has, the more energy is transferred during a collision. At the end of this section, using their knowledge of the relationship between speed and energy, and how energy transfers during collisions, students design a ramp to move a ball a specific distance. They engineer a solution using a set of criteria and constraints. Section 3 transitions students from thinking about energy to thinking about work. This section will take about 10 days. Students will learn about work and simple machines. They conduct experiments to come to the conclusion that simple machines make work easier. In Section 4, students take the information they figured out about energy, work, and simple machines to complete the design challenge. This section will take about 4 days. Students will discuss how engineers build machines to solve problems. They will then research, design, and build a machine using simple machines and energy transfer to solve a problem. By the end of this unit, students will understand how energy transfer and simple machines can be used to design solutions to everyday problems. For more information, visit our website, mySciPartners.com. mySci, inspiring the next generation of scientists.